Hello and welcome back to this course. In the previous session, we have discussed the types of instruction in C. For the type declaration instruction, we have discussed the data types and the number system associated with it. In this session, we are going to discuss the instruction that are used to perform some operations. That means operators in C. So let's start. Operators are the symbols that tell the compiler to perform specific mathematical or logical function. C language is rich in built-in operators and provide the following types of operators. The very first is arithmetic operators like plus, minus, multiplication, division, modulus, increment, decrement operator. Next is relational operators equal to, not equal to, greater than, less than, greater than equal to, and less than equal to. Next is logical operator, that means and, or, not. Bitwise operators, ANDing, ORing, XORing, complementing, left shift, right shift. Assignment operators equal to, plus equal to, minus equal to, multiplication equal to, division equal to, modulus equal to. Similarly, left shift equal to, right shift equal to, ANDing equal to, XORing equal to, ORing equal to. And the last one is miscellaneous operators, size of, ampersand, pointers, and conditional statement. Now let's discuss these operators one by one and understand with the help of examples. Arithmetic operators. Now arithmetic operators are used to perform mathematical operation. The following table shows all the arithmetic operators supported by the C language. Now assume variable A hold 10 and B holds 20. Then this is the table for the operators and the result. Like plus, so A plus B, that is 20 plus 10, 30. Minus, that means 10 minus 20 minus 10. Multiplication, 200. Division, 20 by 10, that is 2. Modulus, it returns the remainder after the division. Okay, so 20 divided by 10 will give you remainder 0. Increment operator, that means increase the integer value by 1. That means if I write A plus plus, then it is equal to 11. A minus minus, then it is 9. That is decrement operator. Next is relational operators. Relational operators are used to check the relation between two values provided. The following table shows all the relational operators supported by C. Now assume value A holds 10, B holds 20 again, and then use these operators and see the result. So A equal to B. It checks whether the two operands are equal or not. So if A and B are tested for equal, then it's not, because 10 is not equal to 20. So it's not true. Next is not equal to, then it will give you true answer. Greater than, then A is greater than B. Of course, it's not true because 10 is not greater than 20. Less than, A less than B is true because 10 is less than 20. Greater than equal to, again not true. Less than equal to, true. Next is logical operators. Logical operators are used to test the logic of two operands and gives a Boolean result. Now Boolean result is either true or false, just as we see in the previous session. In the previous operators, the following table shows all the logical operator supported by C language. Now assume the variable A hold 1 and variable B holds 0. Then A and B is false. That means 1 ending with 0 will give you 0, which is false. A or B, that means 1 or 0 will give you true. Next is not operator. So not of A and B is true. That means A and B is false and not operator will returns the negative of false, which is true. Now this and, or, and not operator is basically the gate, the logic gates that we have studied in physics. So for the logical operation performed by the gate, we have operators called logical operators. Next is bitwise operators. Bitwise operators are used to perform bit manipulation of operands. The following table lists the bitwise operators supported by C. Assume variable A holds 60 and B holds 13. Then the binary representation will be for 60 it is 00111100, and for 13 it's 00001101. Now the very first operator is binary AND operators. Binary AND operator copies a bit to the result if it exists in both operands. If you remember the truth table for AND gate, for input A and B, the output is 1 if both the input is 1. So if you see the same thing with this operator, like in A and B, Wherever there is 1, the output is 1. If any of the operand is 0, then output is 0. Therefore, it is equal to 12. Similarly, there is binary OR operator which copies a bit if it exists in either operand. That means the truth table for OR gate. For input A and B, the output will be high if any of the input is high. So again check in A and B, wherever there is 1, just copy. So 1 0 1 1 1 1 0 0. So it will give you 0 0 1 1 1 1 0 1, which is 61. Next is binary XOR operator. So it copies the bit if it is set in one operand but not both. So basically XOR operator is if the operands is not same, then answer is true or answer is 1. If you remember the XOR gate truth table, then for input A and B, Y will be high if the operands are not equal. That means if you see for A and B, if it is 0 and 1, then output will be high. If it is both 0, then output low. If it is both 1, again output low. Again both 1, again output low. If it is 1 0, so 1 1 0, again 1, and 0 0 for these two conditions. So we'll get the output 0 0 1 1 0 0 1, okay, which is equivalent to 49. Next is binary ones complement operator. So it is unary, that means it only needs a single operand. You can complement of A or B, but not both in one statement. So if complementing A, that means replacing all ones in A by 0, we'll get 1 1 0 0 0 0 1 1. Next is binary left shift operator. This operand value is moved left by the number of bits specified by the right operand. Like if I am writing A left shift 2, that means this value is shifted towards left by 2 bit. So these 0 0 will be shift to left, discarded, and we will get 1 1 1 1 0 0 0, which is this the value. Similarly for right shift operator, A right shift 2 will give you 15. That means this bit will be shifted towards right. These 0 0 will be discarded and it become 0 0 0 0 1 1 1, which is 15. You can try various values and test the result of these operators in code blocks. Next is assignment operators. Now assignment operators are used to perform some arithmetic operation and assign the resultant value to a variable. The following table shows all the assignment operators supported by C language. Here again let's take the value of A 10 and B 20. So equal to, so C equal to A plus B, that means A plus B is the addition operation and the value is assigned to C. Plus equal to means C plus equal to A, that means C equal to C plus A. Add and assignment operator. So it adds the right operand to the left operand and assign the result to the left operand. That means if I am writing C plus equal to A, then A is added to C and the value is assigned to C itself. Similarly, for subtract operation, it's C minus equal to A, that means C equal to C minus A. Similarly for equal to, division, modulus, left shift, right shift, ANDing, ORing, and XORing. Okay, so whatever bitwise operators we have, we can use with the assignment operators also. Next is miscellaneous operators. In C there are 4 miscellaneous operators. First is size of. This is the function that returns the size of a variable. Let's take an example. We have defined a variable int A, and if we calculate size of A, which is an integer, that is 4 byte. Next is ampersand. It returns the address of a variable. Like if I am writing ampersand of A, then it will returns the address of location where variable A is stored in the memory. Next is pointer to a variable. Example, pointer A then points the value stored at the location address stored by the pointer variable A. And the last one is conditional expression. It is a short form of if else condition. Let's understood with an example, that is A is greater than B, question mark A colon B. This statement means that check if A is greater than B. If it is true, then returns A, otherwise returns B. Now what is if else condition? We'll discuss it later on. We have discussed multiple operators in C. Now what happens if lots of operators are connected in a single statement? What will be the order of execution and how the processor will operate with all these operators? So for that we have operator precedence in C. For mathematical, we are familiar with the BODMAS rule. That means the bracket of division, multiplication, addition, subtraction. That means the priority of performing a mathematical operation. Similarly, in C there is operator precedence and we have 2 operator precedence. One is right to left and left to right. So These are the unary operators, that means which needs a single operand. So right to left precedence, that means if these are used in a statement, then it will be executed from right to left. So size of will be of higher priority, then ampersand, then pointer, then minus minus, then plus plus, complement, not, minus, plus, similarly conditional, then assignment. So all these operators will be operated with right to left precedence. That means the rightmost will be of high priority. This is the example for left to right precedence. Like if these are the operators used, then the leftmost will be preferred first. That's all for this session. See you in the next one. Thank you.